So welcome to part 3 of this Riverbed SteelCentral Aternity overview. In my previous video I introduced you to the Aternity console and some typical use cases that support, operations, project owners and business execs would find useful to their roles. In this session I'm going to demonstrate some customer case studies with real-world problems that have been alleviated using Aternity. Customers range from healthcare, retail, through to finance and manufacturing. So while I'm not able to show you exact customer data, the demo system should give you a good idea of the features available within the product to help resolve similar issues with your own customers. In this first case study, an American healthcare provider was struggling with performance of their patient management system on a newly rolled out VDI environment. IT staff were struggling to correlate performance complaints from medical staff who used a variety of endpoints, including desktops, tablets, and VDI. A key factor for why this was missed during a major rollout was a lack of testing during the pilot phase, gathering performance of key business activities as they render on the screen. Aternity has the ability to validate any change in an environment, whether part of a new IT initiative or unexpected issues out of their control. In this example, we can use the Validate VDI migration dashboard within the console to quickly determine if performance of applications are better or worse on the VDI platform. The worst performing applications compared to the existing physical endpoints are on the left and highlighted in red. I can see an application, Meditech, has a slower response time. Using a custom dashboard, I've configured a table showing individual business activities for Meditech, comparing physical desktops and VDI endpoints. The results show clearly that performance has dropped, resulting in tasks taking twice as long. If I browse to a user who has complained of poor performance, change the time to the past week, I can highlight the Meditech app, then highlight the logging activity which the user was complaining of poor performance. I can see from the data that I can validate her complaint quickly because of the traffic light system, with this particular task highlighted in deep orange, indicating a drop in normal performance. I can see she has been using a VDI endpoint, and I can also see that client time appears to be fairly high at just over 3.5 seconds. If I troubleshoot the activity, I can compare the client time and the average times calculated across all endpoints within the estate. I can see here that the average client time should be the region of around about 1 second. Comparing that to the 3.5 seconds experienced on the VDI endpoint, I've quickly isolated the major cause of the issue appears to be with the processing from the client side, potentially indicating an incompatibility with the virtual architecture compared to a physical endpoint. So this would be enough information now to get the application team involved and start to liaise with the vendor to determine if they've seen this before and if there are potentially any new patches or updates required to alleviate the problem. In this example, we have a global retailer who initiated a project to help improve stability and efficiency of applications and their supporting endpoints during the busy sales periods. Having unstable applications severely impacts how quickly transactions can be processed. The less transactions completed, the less revenue for the company. This is detrimental during the key holiday seasons for which the majority of retailers rely on for their largest revenue gains. In the Aternity console, I can browse to the device health dashboard. This dashboard allows support and operations teams to track errors and crashes throughout your organization by viewing the latest individual health events with all their details. It can also be used to search for patterns with specific types of health events to find correlations with attributes like the device model, RAM size, CPU cores, location, etc. I can see here that there are various health events raised over the past week, with the largest being application crashes. If I filter on application crashes, I can see the health events by device name are showing that the majority of these crashes are occurring on smartphones. I can then see the associated username also. If I filter on a user's smartphone, I can see one of the core applications, point of sale, is affected. I can verify this again by filtering on another user's phone. For the retailer, knowing now they have a problem with the application, and importantly, they can understand the scale of the problem by seeing the trends of the crashes each day below. IT support are traditionally reliant on end users raising tickets, but if the problem occurs regularly, you can get into a trend of users simply accepting that the application isn't stable and they'll carry on persevering, even though it affects their ability to do their job effectively. If I select the point of sale application, I can now have the details of the crash with the details of the exception error. I can now liaise with the developer of the application to help resolve the problem as quickly as possible. In this case study, a financial services company were trying to reduce IT support costs by enabling first and second line support teams to make better decisions when escalating problems. Traditionally, first line support would deal with simple requests like password resets or access rights. When it comes to performance issues, highly likely the network will be blamed. The ticket's often thrown over the fence to the network team, who then run tests to discover that it's not their problem. Meanwhile, the end user the whole time is still having the issue. Aternity breaks performance metrics down by client, network, and server time. So this enables more accurate analysis to determine where the problem could lie. Aternity also has integrations with service desk platforms such as ServiceNow. So tickets can now be automatically generated on behalf of users. In this example here, we have both hardware and application crash issues being raised via the API. The hardware issues, disk failures in this example, can be automatically assigned to the local IT team supporting the end user, who can then contact them directly to remediate the problem as quickly as possible. Back to our support agent, in this example, a user, Marianne Parr, has called complaining of poor performance with the Thomson Reuters application. The support worker can quickly search for the user, look at what the last device she last used was. In this case, we know it was her desktop machine. Here we can determine if there are any issues with the device itself. CPU and memory look normal, a bit of disk activity. There are a couple of recent health events appearing to be related to Outlook and an Excel patch update also. I can see on the utilised applications that Thomson Reuters has a low UXI score, which is all about the health and stability of an application. If I now monitor Thomson Reuters, I can see usage of the application across the entire enterprise. Here, I can see an amber activity score for the sales department for which Marianne belongs. As mentioned in my previous video, an activity is an end-user interaction or an event in a managed application, like a mouse click or pressing enter on a keyboard, together with its response, a change on the screen. So over time, we baseline the score, indicating what the average time should be to perform that particular activity. Using a traffic light system, green would indicate normal performance, amber a moderate drop, and red a major degrade in performance. Here I can see the sales team at amber, indicating a wider problem affecting multiple users. I've now validated the user's issue, but I've now discovered a wider problem. If I filter on the sales department, I can see below that the activity with poor performance is search filing. If I now troubleshoot this activity, I can see it appears to be affecting the Miami building, which is where the sales team are based. However, below, I can see that there's one particular server that is red, with much slower response times compared to the others. I now have enough evidence and confidence to be able to escalate this with the vendor to ensure that their cloud-hosted server instance is operating normally. For this case study, a multinational manufacturing company had outsourced much of their IT infrastructure to a global systems integrator. The company wanted to ensure that SLA compliance was still met, particularly now that the majority of their infrastructure was out of their control. Aternity was the perfect fit because we benchmark performance of critical business activities. Any deviation from this will give alerts and can also be tracked within our own SLA dashboard. So this feature helps both the customer and the SI provider to ensure that the quality of service being delivered is met. For an SI that consistently meets SLA targets, this will give greater confidence with customer retention also. In this example, the manufacturing company have migrated their order execution application to the SI Cloud Managed Platform. If I navigate to the SLA dashboard, I can see all my critical applications sorted in order of compliance against the SLA threshold set. Aternity will automatically set these SLA thresholds based on the average response times. However, a customer can change these thresholds and manually define them if required. If I highlight the order execution application, it will filter the departments and also countries who utilize the application. The two activities which are in breach of the SLA are map view and login. All the other activities appear to be fine and meet the thresholds. So by selecting the login activity initially, as this is in breach by a larger percentage, I can then troubleshoot the activity. So this view is compelling as we can see there are two different business locations who have been executing the activity, and it appears the Los Angeles building is the only one affected, with Miami running absolutely fine. The response times in Los Angeles are far higher, indicating a potential problem with connectivity from this site. Both the customer and SI can work together to resolve the problem to see if there's potentially a routing issue for the network to their cloud platform, or maybe another factor affecting the drop in performance.